I love how you can use their searches.
I like this.
Then you have to go to Wimpy Hall and pay for it.
Yeah, I don't know. That's the part I find weird.
That's what I'm doing today, because I just got paid for something.
What am I serving? Yes.
Okay, first about the case study. Announcement case study.
Oh, shit.
I received one group's requirement. They want to be the same group.
When?
Okay, if that is so, for the rest student, I will assign you accordingly. Okay? Because I didn't see any. If you get partner, you have to let me know. I say by Friday, right? But in the past 2 days, only one group.
Alright, I'm emailing you right now.
Tell you by Friday. I didn't know.
Yeah, not just personally. It's you have to let me know personally or by email. Otherwise, how I know your mind who want to be the partner,
I
right?
don't know.
Oh, send me an email.
I think I'm doing.
The reason I want to send an email because it happened before that one student was claimed by 2 groups. Say, okay, I want to be with Jack. And Jack said, why I belong to 2 groups? If you send me email, include all the potential partners. That's everybody knows. Okay, we agree. That's okay. We are in the same group. I had this happen before. One student was assigned to 2 groups. They both claim I have this person. Well, that's because like one person you tell me, okay, I want to be with like Jennifer, and Patrick tell me that I want to be with Jennifer. So who will have Jennifer? Nobody, right?
Who I pick? I get to pick what group I'm in.
Yeah, so basically, send me an email, like John has done, send me an email, include all your,
I'm already in a group.
yeah, in the group, and then let me know. Yeah, if somebody have objection, oh no, sorry, I have some other group. I don't know. So today by, let's say 5 p.m., okay? I think it's a long time, okay, 5 p.m., send me email, include your friend who mutually agree be in the same group in this email, okay? I think you can handle that, right? But I don't want this like previous example happen where one student was claimed by 2 groups. And they have some embarrassing, right? Decided, what's the problem? And the problem is also belong to me at that time. One group told me the last name, another group told me the first name. So I literally assigned this student into the 2 groups. The same students. But one group told me the last name, another group told me the first name. Okay. So let me know. We still have time. Okay. How many of you guys commute to the school? How many of you commute?
How far commute?
Commute? Do you find any problem today or yesterday? No?
I had to drive here yesterday.
Huh?
I had to drive here yesterday from Fayetteville because I had to go to Fayetteville, and
Yeah.
a lot of the roads.
Very bad, right?
Yeah.
Very bad. Yeah, in Cumberland County, Fayetteville area. Well, yesterday I tried to pick up my daughter on 5:30. Usually it's like 4 minutes from my home to my daughter's daycare. 4 minutes. So I say 6 o'clock. So I come out on 5:30, and it's blocked. Okay, I come back, route again. The second shortest road is blocked again. Then I have to open the ways. You must know this. You should know this one because it can be very useful. WAZE, this app, Waze. I definitely recommend this app to you guys. Yeah, it's very useful. And then it shows so half an hour. I have to detour to home meals. So then I have to call the school, say, I'm sorry, I'll be late. Well, even it's 4 minutes original. And this morning is the same. I find this road is all still blocked. So I asked my wife to send my daughter to the school. But when I come to UNCP, initially, even Waze say, okay, I will be here like 20 minutes before like the opening of class. But still some place is blocked. Waze didn't report. I have to detour. Finally, I arrived at the parking lot on 10:08. It's on time, right? So when there's some problem, especially in the winter time, we are coming. Later, there's some flooding problem. Use this app. This is even better than Google Map. Because this is like the customer the reports, like reports say this road is blocked, has flood, or have a hazard on the road. Even the cops they report. So you will know that's better by using this app. Okay, just want to share with you guys. So let's continue our study on the quantitative method of location decision. We have discussed this example, given these 4 potential locations and their corresponding fixed cost per year and variable cost per unit. We can calculate the total cost function for A, B, C, D. And if we look at this graph, obviously location D is always more expensive than all the rest 3 locations, no matter what is the output range, right? So, but in the initial range, B is the best, and the C is the best in the middle range, and the A is the best after we pass in 11 1,111 units. So then we know, okay, given our demand forecast, which location is the best choice for us. That's the first example. So, second example is called factor rating model. Factor rating model is an approach to evaluate the location by considering not just the quantitative, not just the number, but also qualitative factors. Okay. So here's the procedure. First, before we think about, okay, we decide to open a retailer store, right? Grocery store, even gas station. We have to think about which factors are important for us to open this new business. So you determine, or maybe your business partner together determine which factors are relevant, important. Then second step can be the most important step, is to assign the weights for each location, for each factor, sorry. You think about, okay, if you open a retailer store like a grocery store, you want to be close to the market, right? Traffic, right? Size, and like the rental costs. They're all different factors. Then you then decide which factor has the highest weight or second highest weight. Typically, we sum together the weights should be equal to 100%, equal to 1. Then third step, we decide our common scale for all factors. If let's say we set a minimum acceptable score, which means, for example, if we think about, okay, this location, the rental cost is very important. And then we set it's from 0 score to 10. So 10 is the highest score. It can be the cheapest rental cost. 0 is probably the most expensive rental cost. And you set this from 0 to 10. And then everybody in your group give the score. Or maybe you just give the score. Okay, 7, 8. And if let's say you want to set a minimum, you say, I can't afford, too expensive. So the rental cost score must be about like 5. Otherwise, even other factors very good. I can't accept this location. Right? Then the fourth pass, you score each location alternative. So location 1, 2, 3, you give the score for each factor. The fifth step, multiply the factor weights by score for each location and sum them together. So you get the kind of like a weighted average, right? Weight times the factor rating, add them together, so it's weighted average. And choose the location has the highest composite score, unless it fails some minimal requirement for some factors. Let's example, then you will not understand how to do that. So in this example, we want to consider, so it's not we, a photo processing company want to consider to open a new branch. But first I would say this photo processing industry is a not very good industry nowadays. But yeah, let's say if they want to open a new branch store. The following table includes information on 2 potential locations, location 1 and location 2. Right? And for this photo processing company, they have list 6 factors they think are important for them to make the location decision. What is close to the existing source, raw material, something like that. Traffic volume, right? Rental costs, most important. They give 40% with 0.4 for the rental cost. Size, layouts, and the operating costs. It's also important, and 2 costs are important. And then you can see, and together, the weight is 100% equal to 1. So what you have to do is that, okay, they already give you the score for each location for each factor, right? What you have to do is that you multiply the weights by the score of each factor. For example, the first factor, proximity to existing source. The weight is 10%, the score for location Y is 100, so you use 10% multiply 100, so equal to 10. That's for location 1. For location 2, 60 points times 10%, you get 6. That's the points you get for location 2. You do the same thing for all these 6 factors, you sum them together, you get the composite score for each potential location, location 1, location 2. Which one has the highest score should be your best choice. Since here we don't have minimal score requirement, so you just compare the composite score. I'll give you guys 8 minutes, try to do this problem by yourself. Clear?
I don't have pen or paper. Yes, I am. My life is not good.
paper again?
I want to work together.
Work together? No, it's
Yeah.
also working
One
together.
person.
You should have your own paper.
I love people that work together.
Wow.
Okay.
Try.
Yeah. Nice try.
Oh, you can see the number. So,
I'm so lazy. So lazy.
have the weight.
I got it.
I'm so lazy. Use the weight multiplied by 4. That's 10% multiplied by 100. And then you do the same thing for each factor. You add them together. Multiply, that's number. You add them together, that's it.
So this one's better.
Summation is 1. So
Okay.
these two equations.
Okay.
Compare them.
Yeah, it's too big.
Like 9. Probably want to double check for the first location. Let's go. Oh, 80, 90. You mean the last row?
No, the size, the row with size on it.
Oh,
It's
side,
86.
okay. Oh, 86, 92. Oh, thank you, side. Oh, by the way, I forgot to mention that I didn't give the whole exam back to you because I will use some question in the future. But you're more than welcome to come to my office. We can review exam. If you have concerns, so which question you have made mistake, we can review together. Because I forgot to mention that. I can make a mistake, so maybe you guys full score if you want to review. But if we find you make a further mistake, it's happened. One student come to my office before, and then we find I made a mistake on grading. Unfortunately, he should have missed more points.
Dang, that's when they messed up.
Huh? What's your results, Chen?
It's supposed to equal to 1 though?
So, okay, so here, just the weight. That's when you multiply that.
Yeah, it's point one times 0.6, right?
No, it's 0.6, so it's 80, right? Oh, it's 60.
Yeah, 0.6.
Why is 0.6? How do you guess 0.6?
No, that the answer is 0.06, right?
Those points of 100 times 0.1. It should be 10.
I was just doing guess all, then I was gonna just 106.
No, Chad, you have to do it again.
Man, no, I'm dropping out. Sorry, coach.
That's what I missed.
You mess up too?
Yeah.
Yeah.
I don't know.
Oh my god. Dr. Charles, how hard will it be for me to drop out today?
What's your boss?
I'm gonna drop out today. I hope that's okay with you.
What's your exam? Score is good.
Yeah, I'm still gonna drop out though.
Chad.
I'm gonna do it. Do not hold me back.
Okay, dude. You're so
Okay.
close.
Yeah, that's good.
I know it's so funny.
Uh-huh.
The day before.
Just better, so we just have to.
And you add
I think we
No,
This
only
you can't withdraw at certain
100 for each.
Why did you drop it out?
You should
Yeah.
She's a stripper now. She makes a lot of
You
money.
choose the best between.
Good for her. That's awesome. Do you add them up? I don't know if I did that right.
You add them together,
That's not right.
Yeah, that's
Be a stripper.
What
You are right.
did I do?
You are right.
I don't know what I did there.
You are right.
Nicole. My,
So you take the
it's
five.
Friday.
So you basically have a green glass that you drop.
How is that?
I wouldn't.
I got 42.
So there's your 23.
What?
Oh wait, I forgot 60.
What?
They're like
They want the ratings.
Yeah.
See that, like,
You add them.
Maybe I don't like that.
What?
Yeah, you need to add these 6 schools.
Bye, friend.
Then you can
Bye-bye.
summation. Summation, which summation is larger than that. Straight.
Yeah, I got 456 now. I don't know if that's.
Okay, great, great.
I don't know. God, I can't talk.
I agree with you on that, but
Still no clue?
No.
unless you want to start your own business.
So you have the weights, right? And then the score for each factor. So you multiply the weights by the score. For example, for this, the first location, factor 1, gets 0.1 times 1 equals 10.
Yeah.
And do the same thing for each factor, each location. And then add them together. For example, this is 10, this is this is like 4, right? 0.051, 84. You add them together, you get the composite score. Clear?
Yeah.
It's clear for you?
What? Yeah, I emailed you both.
Sure.
At the beginning of class.
You already know?
I did at the beginning of class.
what is this one?
So you multiply by this by 0.1 multiplied by 100 that's 10, right?
So Nicole, no, you can drop out now.
And you add them together.
Drop out now.
Oh, I have to.
What do I
Yeah,
do?
you should multiply by the weights.
I'm thinking about drug dealer or I think I would be a nice
Follow your dreams.
Oh wait, that's
Good
good.
Lord.
This one is
That was messed up. I know that for a
yeah,
fact.
yeah. This score should be correct. But the first one, let's double check. So it's 100 multiplied by 20.
I messed up right here. I did
Oh yeah.
7, not
This
70.
should be
All right.
28.
Yeah,
Oh no, yeah, 28.
I forgot his
Yeah,
zeros.
yeah, that should be good.
Still dropping out though.
You can put the international marketing to work if you go drug dealer, man.
Yeah. Thank you,
I
Chad.
know. Hey, don't bring me down.
I will bring it out, Chad. That is the dumbest decision you will ever make in your entire life.
So points are 10.
Why are you doubting me today?
Yeah.
But like I said, like people say,
Because it's not a goal you should have in life.
Last one is most
That should be a last
1.45.
resort.
It should be 1.5.
Wow, that makes so much. I kept so many cards.
I doesn't even know about that. What?
Okay, I can see
Jen
most
said
students have
myself.
finished this example. Let's do it together.
Strip club. And we're gonna work.
So we have
I'll work
6
it.
factors. I won't write down all six factors, but
I don't care.
so we have location 1 and location 2.
Gonna ride your bike.
We need to guess the score for each factor and then add them together. So the factor 1, so it's 10%. What's the score for location 1 for factor 1? What is score? 10 is 0.1 times 100, so it gets 10, right? What's about location 2?
4. Oh, no, 6.
6. Yeah.
I was going down. No.
I know. So you got 6, right? So you did the same thing for the second one is 4, right? 0.05 times 80, which is 4. The same thing is 4. So you do the same thing for all these 6 factors, and you guys together, sum them together. What's the composite score for the location 1? 70.6. What about location 2?
82.7.
82.7. Very good. So you can see Now the decision is pretty straightforward. Which is the better choice? 2. Location 2 is the better choice. Right? Some students, some people they were rating it different. They say the lowest score is the better. If that is the how you rate that, definitely okay, you choose the lowest. But in this example, we use the common sense, right? The higher score means better. Right? Now it's very interesting. For example, our teaching evaluation in UNCP, the 1 is the highest score. When you evaluate me, that's you evaluate okay. So if you give me 5, I will be very upset because 5 is the worst score for teaching evaluation. Yeah, 1 is the highest score. So if you get 1, it's good. You get 5, it's the worst teacher. So yes. Yes.
Wait, on the
Teaching evaluation.
Really?
no, that's the other way around. One is strongly, one is the disagree, and 5 is agree.
Trust me, I have teaching evaluation every year. I can show you my teaching evaluation last semester. It's pretty good. In this session, I probably got like 1.1 something, 1.2.
Ooh. Not,
Everybody say no, you guys don't like me like a Chad. So this semester, okay,
I like you. I was gonna drop out. Difference.
Okay. Yeah. So yeah, that's okay. So but this is very strange. So when we explain like some faculty applied a job for some other university, they have explained why I guess 1.3 is a great teaching evaluation or 1.5 or even 2. It's good because in our system, 1 is the best, 5 is the worst. But in most schools, like when I was in Purdue, 5 is the best. It's common sense, right? So that means when you give the rating, you should understand with your partner, okay? You give the score 100, that's the best. Not because, for example, this one is very confusing, right? The cost. When you give 90 of the cost, the score, which means most likely it's cheaper than 70, right? Because it's cheaper, the better, right? Instead of, okay, it's 90 is the absolute cost. So that's the different way you to give the score and evaluate. So that's the factor rating method. Now, here is the way how to solve that, right? You guess the calculation for the score for each factors, you sum them together, 17.6 versus 82.7, you guess the best score. Okay, it's clear for factor rating? Everybody's clear? Now, we come to the last quantitative method of this chapter, okay? It's called a center of gravity method. So this method is to locate a distribution center which minimizes the distribution cost. So in this method, we treat the distribution cost as a linear function of the distance and the quantity shift. Basically, you look at, okay, if you're 100 miles away, and how many units you shift per day. Let's use this 100 miles times the units, the quantity you shift per day, right, or per year. The quantity to be shipped to each destination assumed to be fixed. So you know it's advanced. It can also explain as you have the perfect demand forecasting for future, right? You know that next year I will ship 10,000 units. Usually it's change, right? Nobody knows how many you will ship next year. But let's say you have very accurate forecasting or estimation. Then we need a like map or GIS or even Google Map should be fine. Show the location. This map should show the location of destination, and it should be very accurate and drawn to scale. Now we use the coordinate system to determine the relative location's position. Right, that's the example. Right, we'll show that. Before I jump to this example, let's talk about the 3 methods we have introduced here and how this method can be used for different fields. So you do still remember the first quantitative model we used the last class, introduced last class, to analyze the location decision? What's the first method we introduced?
Like the linear one?
The cost, right? The cost volume analysis, fixed cost plus the variable cost, right? The second is what we have finished. It's called factor rating. The last is center of gravity. Well, you maybe want to know why we need so many different methods for location decision. And those methods are different, right? Think about supply chain. Then you understand, right? Very simple supply chain. Oh, sorry, it's not. Yeah. Let me ask you, what does M mean here? Manufacturer. Very good, John. What does D mean? Distributor. What does R mean? Retailer. So it's very short supply chain. We can have a supplier, we can add a lot like wholesaler. But think about the first method we have mentioned. It's called cost volume right? Analysis method, right? For the first method, we talk about, okay, we analyze which location, best location based on the cost, right? This method, which player in the supply chain do you think fits best for this method when we decide location? Manufacturer. You are right, I agree with Jennifer. Why? Why manufacturer is the best? Why not manufacturing? Why not factor rating method? We have just talked about factor rating. I'll give some factor, well, we can also do that.
You're more concerned about the cost, production cost.
Yeah, that's right. And also think about some assumption. This is related to the production, right? Quantitative the production. The fixed cost, variable cost, very typical plans, right? So this method work widely for manufacturing industry, right? Factor rating, that's what we have done 10 minutes ago. For this method, which player in the supply chain do you think fits best? Retailer, right? This example is pretty obvious. They want to open retailer store. Why retailer store fits best for factor rating?
Because you're talking about the size, the layout, the volume, you're talking about all the things that you need to think about when you're talking about an actual brick and mortar store.
Good.
Proximity to customers, so being.
Yeah, the first thing, as both of you, in fact, you implement implies that it's much more complex, more factors to consider than manufacturing. You manufacture most likely cost, right? So manufacture, right? But for retailer store, something is quantitative, something are qualitative, right? Close to your customer, that is really hard to accurately imagine. We can give the score, but the score is also subjective. You give the score, it's already combined the objective measurement and subjective decisions, right? But this method is perfect for retailer store. Combine the qualitative factor and the quantitative factor, and the group of people give the rating and then gets the results. Because for retailer store, it's not easy to quantify that. Okay, now no surprise, for last method we are talking about now is about which player? Distributor, right? Distributor, what's the most important thing for distributor?
Being in between the two of them.
Yeah, it's the transportation cost, right? It's the distance. Because that's for his role is pretty straightforward, right? I get the products from manufacturer. I need to distribute to the retailer store. That's their role. So for them, the most important thing is not like the close to raw material. It's not so many factors to consider, but the distance. Okay, transportation cost is the most important thing. Then you can see why. Well, if I don't explain, probably you get these three tools, but you don't understand why we need these three tools and in which case we should implement three different methods. Now you should get the idea. Okay, come back to center of gravity method. The method itself is pretty straightforward. The first basic method, if the quantities to be shipped to every location are equal, that means, okay, if you satisfy the 4 retailer store, okay, each retailer store has the same demand compared to others. Then you just calculate the average coordinates for x. It's pretty easy, right? Sum xi together divided by n. And the average coordinate score for y bar, sum yi together divided by n. Then x bar, y bar should be the center of gravity, and it should be the place you build this distribution center. It's very clear, it's like a trivial method where everybody like understand why it's happening. Right? If your demand is the same. Right? Now, the first example can be another very simple example for you to do. So we have 4 locations, right? D1, D2, D3, D4. 2, 2, 3, 5, 5, 4, 8, 5. That's these 4 locations. We can refer to this graph, right? D1, D2, D3, D4. I would think about like this is like D1 is Charlotte. Let's talk about North Carolina. D1 is Charlotte. D2 is probably Greensboro. D3 is Raleigh, and D4 is like Greenville. Is that kind of correct, right? So that if we have these 4 retailer store for our business, Charlotte, Greensboro, Raleigh, and Greenville, then we have to decide what is the center of gravity to build our distribution center. I'll give you guys 2 minutes should be enough because in fact they already got summation for you. Use this formula, previous page formula. Sum them together, divided by n. Then you should get the center of gravity.
Got that? Wire trigger, right?
Yeah. Too simple.
I was just like, please don't tell
Too
me I'm
simple,
wrong.
right?
But I feel stupid.
Yes.
Okay, right.
I think that is the second simplest question compared to the efficiency utilization example we have do that for
Chapter 5.
Plus 3. Divided by A.
For each, right?
Yeah.
X coordinate, Y coordinate.
Finish that? Yeah, wire trigger, right?
Or we're just taking the average.
You add them together, you get the summation of xi, and then you divide by 4. N is equal to trigger, right?
Okay, I can see many students have finished that. That's we feel so boring for doing that question, right? So by the formula, it's very straightforward. So we need to guess the center of these 4 points, and for the center of these 4 points for x bar, which is summation I from 1 to what? How many points? How many data? How many locations? 4, right? xi divided by 4. And then you can add them together. In fact, they already calculated for you. 2 plus 3 plus 5 plus 8 divided by 4. What's the final result? 4.5. You do the same thing for y. Divided by 4. You should get equal to 4. So your center of gravity is very easy to calculate. Then you should build your place in some place is 4.5. So that should be 4.5 something. That's 4.5 something between Greensboro and Raleigh. Probably it's Durham, someplace like that. Right? Or maybe Burlington. I don't know. Maybe Chapel Hill. That's the area. You should have your distribution center. Makes sense, right? If that's Charlotte, Greensboro, Raleigh, and Greenville, if they have the equal demand, then probably like the Chapel Hill, someplace, or Durham is the best choice. Okay, this method is so trivial. Do you see any potential problem of this method? Or maybe some assumption is too strong for you?
It doesn't take into account the cost of the land in the area that would be good.
Definitely, that can be a problem. If you find the center is in Manhattan, then you probably there's no way you can do that, but it's no smart to do that in Manhattan. But in most situations, like if we talk about North Carolina, even you talk about okay, you find something is Raleigh, well you switch like 10 miles, probably can have a cheap plan. So it's for most states in the United States, it's not a big problem, but you are right. But it's like Europe, definitely, it can be a problem. If the center is like in Paris or London or New York City, that can be a problem, right? But another problem I would say is that it's so trivial. That must be something we can't capture by this trivial method. You can see the assumption here, right? What's the assumption here? The assumption here is that the first sentence, quantities to be shipped to every location are equal. Do you think it's too strong assumption? Yeah. Yes, of course. When we talk about these 4 cities, maybe, I don't know which store you open, maybe think about maybe pharmacy, maybe those big deal. But if it's a grocery store, even gas station, I talk about these 4 cities like, okay, Charlotte, Greensboro, Raleigh, and Greenville. Well, which city should have the biggest demand? Charlotte or Raleigh maybe, right? It depends. But probably Greensboro has a much lower demand than Charlotte or Raleigh. At least Greenville, right? Greensboro, I don't know.
But couldn't you use a weighted average then, and then use the coordinates of the weighted averages?
Exactly. You already guessed the method we'll talk about, Patrick. So, exactly. If you have the different quantity, you should assign different weights. right? It's easy. If you have 100 trucks per day shipped to Charlotte, only 1 truck per day shipped to Greenville. But there's no point you set the distribution center in the middle of Charlotte and Greenville, right? You should set much closer to Charlotte than Greenville. Right? Makes sense, right? So we definitely should consider the demand and assign different ways. Well, if we don't have this assumption, we can still handle that if the demand is different. That's this model. When the quantity to be shipped to every location are unequal, usually that's true, right? Very strange that is equal to each other. You can still obtain the coordinate of the center of gravity by finding the weighted average of the x coordinates and the average of the y coordinates. Like Patrick already think about that, right? So Q is the quantity. Think about this demand and forecast. You think about these 4 locations. Next year, next few years, demand and forecast. Okay, times the xi divided by summation of the demand or quantity. So it's the total shipping quantity. Do the same thing for y bar. Summation yiqi divided by summation qi. Where qi is the quantity to be shipped to destination I, and xi, yi is the same. Please write down these 2 formulas, and I will go to the example on next page. Oh, does that make sense for you for this formula? Right? Makes sense. And then we'll see the difference now. Everyone gets the formula? Okay. We still have the same 4 locations, D1, D2, D3, D4. Say Charlotte, Greensboro, Raleigh, and Greenville. But now the weekly quantity or weekly demand is totally different. Right? Charlotte 800, Greensboro 900, Raleigh 200, Greenville 100, D1, D2, D3, D4. Then you need to multiply the x with the quantity, sum them together, and then divide by summation of the quantity. That you get the x bar. Center of gravity is the weighted center of gravity for these 2 locations. Do the same thing for y, and then tell us what is your center of gravity results. Give you 8 minutes, should be enough. X bar equal to summation xi qi divided by summation qi. So the summation is I from 1 to 4 because we still have 4 locations. Same thing for y. Okay. You can see the change, right? Now you should have 4.5, 4. Now it's totally switched, right? Yeah. Finish it? Same.
I'm doing it the hard way.
And we divided 2,000. Okay, I can see many students have finished this question. Let's do it together. So, for the numerator, is summation xi times qi. So, it's 2 times 800, right? Plus 3 times 900, plus 5 times 200, plus 8 times 100. And what's about denominator? How many? 2,000, right? It's already calculated for you, 2,000. And then, what's is your x bar in this example? 3.05, right? So you do the same thing for y bar, but the difference that you guys like 2 times 800 plus 5 times 900 plus 4 times 200 plus 5 times 100 divided by 2,000. Then you get 3.7. So now you can think about that. Okay, originally if we don't consider the shipping quantity difference, the center is 4.54, but now we get 3.05, 3.7. Look at the graph, you can see the difference, right? Originally we get some place like Durham, right? 3.54, right? Some place like Durham, right? Or Cary. But now we get this 3, that's probably like High Point or some place like this. The reason is very obviously because if you look at the demand, our major business are in Charlotte and Greensboro, right? So that's why like High Point should be the place we set up our distribution center instead of we move to the east to like Cary. Right? But if we don't consider the quantity difference, then you made a mistake. You set the distribution center in Cary, well, which is not smart because most of your truck will travel to Charlotte or Greensboro. Is it clear with this method? Okay. Now we have these all three methods for different players of content when we make the location decision. Okay. That's the end of today's class. We have finished chapter 8. Let me know your preference of group number. Okay. Not just your preference. Group preference. Okay. Very important. See you guys next week.